Are you curious about what data science really is, and why it's one of the most in-demand careers today? In this video, I'll break it down for you. What is data science? The essential skills you need to get started, real career opportunities, and the complete workflow, from raw data to valuable insights and predictions. This is your roadmap to the world of data science. Let's dive in.
Unlock the power of data by starting your career with data science. So in data science, what we do is we transform the data into actionable insights and drive innovations. So this data science, we all know that AI, ML, data science, these are the job roles or career uh, in high demand, right? So we have to start our career with a data science, which is a baseline for AI, ML, generative AI, agentic AI. So you just search like what are the skills and what are the current market trends about data science, AI, ML. So you will see all these things like AI, machine learning, deep learning, data science, all these things. Okay, so if you talk about the rare qualities of a data scientist, that they can find data scientist or a data analyst. Okay, I'm taking both the terms, data scientist and data analyst. So both they will find the order, meaning and value in both structured and unstructured data. So guys, a simple one, like, so why we are discussing about data science, machine learning, Python, why there is a artificial intelligence, why there is a generative AI, why the people are losing their jobs because of AI, ML. So from where actually the origin of these job roles starting. So the main reason or the main factor of these job roles is data. So what do you mean by structured and unstructured data? So unstructured data, I will give you a simple example like your history, guys. So you are chatting with your friends. So the chatting data will be stored in somewhere. So this is what a unstructured data. You are watching a video in a YouTube, on Instagram, right? So how much time you are spending and what video you are watching. So that is a unstructured data. Your messages, MP3s, MP4s, text messages, voice messages, everything is unstructured data. So in the current market, there is 80% of unstructured data and 20% of structured data. So structured data in the sense the data which is stored in a traditional relational databases in the tabular format. The data which is in the tabular format, we call it as a structured data, right? As a data analyst or as a data scientist, we are responsible to find out the insights from both structured and unstructured data. So why there is a demand? Because these qualities they need. So they need to play with the data. They need a skills to handle the data, to understand the data, to draw the insights from the data and make the predictions. Those predictions, organizations are going to drive their businesses, right? So the high demand for data scientists because they provides the hidden insights. So what are the hidden insights in the data? The data scientist as a data analyst, we are responsible to extract those things. Data science, it's a interdisciplinary field. What does it mean? It is not, it's neither a tool nor a technology. Data science is neither a tool nor a technology. So it is a combination of multiple fields and tools. So here, the first thing we need a programming skill. Hacking skills is nothing but programming skills. So which is the programming language high in demand in the current market for data analysis or for data science? So there are two programming languages you heard about. One is Python and R. So these are mainly we use it in research areas, in academics. The next skill set is about maths and stats. So which maths we need? Do we need engineering mathematics? No, up to intern. So if you have a basic understanding of mathematics and statistics, that is enough. So for in mathematics, so most of the time, whatever the algorithms we have in ML, DL or AI, it's coming from, a linear algebra itself. Okay, and the third one is a domain knowledge. So if you want to create any predictive model, or if you want to analyze your data, so first and foremost, you need to understand the business. What is your business? What kind of problem you are going to solve, in which industry, what is this industry about, how the operations works. So you need a domain knowledge of the business. Okay, so making all this a data scientist. So in data science, we need to develop a programming skills, we need to develop maths and statistical skills, and we have to develop a domain knowledge. So obviously the domain knowledge you will get once you start working in that uh, project or in the company. But before this domain knowledge, it's in your hand that you have to develop your programming skills, you have to develop your data visualization skills, and you have to develop the maths and stats skills. So in interviews as well, so the first focus is on programming, maths, stats, ML. So first they will test you how good you are in, because they will transfer the domain knowledge to you if you know this one. Okay, so in our course we are covering programming skills, we are covering mathematics and statistics skills, we are covering data visualization skills, and we are covering data analysis skills. So what exactly as a data scientist or a data analyst we do in real time? Okay, so we have to follow a step-by-step approach, guys. It's not like randomly we do these things. So we start with a business problem. So what is the problem? Let us assume that I want to create, or I want to develop one product or one tool which makes the prediction about diseases, or which make the prediction about whether a customer is going to purchase this product or not. So that is what my business problem. Okay, your work as a data scientist or a data analyst starts with a business problem. What is the problem which you are going to solve? So I am going to solve so and so problem. Okay, so after understanding the business problem, you start collecting the data. That is what the first step, data acquisition. So we have to extract the data. Okay, we have to extract the data from various sources. So just now we discussed like the types of data. We have structured data and we have unstructured data. So both the data, if required, we have to extract, okay, from various sources. Sir, what are the sources in real time we used to store the data, like databases, or databases in cloud? Okay, how do we extract the data? What we need? So again, we are going to use our tool called Python. Okay, so if your job, or if your requirement, or is the project about making a predictive model, or developing a predictive model, or machine learning algorithm which will make the predictions, then we have to use Python. Okay, so using this Python, we are going to extract a data from multiple sources. Okay, now after doing the data extraction, your data not always be ready for doing the analysis, or for developing the reports, or for developing the machine learning algorithms. So we have to clean the data. So that is what the first step. So data acquisition and data cleaning. Whatever the data we have collected, we have to clean it. Okay, so once the data acquisition and cleaning part is done, then we move to exploratory data analysis. Exploratory data analysis. So this is the important step. Okay, so in this data exploratory analysis, we are going to analyze the data, we are going to understand the patterns, we are going to understand the relationship between the data. Okay, either by using Python or Power BI. So there your Power BI tool comes into picture to analyze the data. To in exploratory data analysis, what we are going to do is we are going to feel the data. We are going to understand the data. Okay, so with Power BI, Python, here we are going to use our statistical skills. Okay, so what is the average? What is the median? What is the mode? What is the distribution? What is the correlation? What is the hypothesis? So all this Python, Power BI, statistics, we use under exploratory data analysis. Okay, means I am saying that we can use Python to explore the data. You can use Power BI to explore the data. Okay, tools, you can use anything. It's all about understanding the data. To understand the data, which tool is comfortable to you, you can go ahead with that. Okay, so let us assume that I am using Python. So in Python also we can create some visuals, which are static visuals we can create, and we can understand the data, we can understand the distributions, everything. So once the exploratory data analysis part is done, again, if required, basically this workflow is an iterative process. It's not just a straight process that first you do this and after that again you don't have to come back. But it's not like that. So it's a iterative process. Iterative in the sense, let's say for example, you are collecting the data, you are cleaning the data, and then you are doing the exploratory data analysis. So you found some you got some insights. So for that again you go back and collect the required data and do the data cleaning. So all these steps are iterative. Okay, so once the exploratory data analysis part is done, we move to feature engineering. So in feature engineering, what we do is we create a new features. So from the existing data, we are going to create a new features. Okay, so once the new feature, depending on the requirement. Okay, let us assume that I have a date of birth. Okay, so date of birth I have in the form of, let's say, month, sorry, day, month, year. Okay, now let's say from this date of birth, I want to create a new feature called age. What is the age of this person? So we don't have an age, we have a date of birth. Now I want to create a new column called age. So this kind of new column creation, we are going to perform under feature engineering. Okay. Once the feature engineering part is done, there your machine learning, model building. Okay. So here you can use machine learning, deep learning, or artificial intelligence, which the current algorithm. So you can use to develop your model, to train your model. So again, here we have multiple models. There is no single model, or there is no guarantee that this particular model will give you a better results. So this machine learning and data science, it's all about experimentation. It's a experimental job, means we have to experiment different algorithms, and then we have to deploy the one, or we have to use the one which is giving the best score. So nobody will give you a guarantee that so this algorithm always gives you best results. So depending on the data, depending on the patterns, we have to understand, we have to try all the algorithms. Okay, so in machine learning, mainly there are two type of problems which we are going to solve. One is supervised and other one is unsupervised. Okay, so in supervised, so there is a data, there is a input data, and we have some target as well. Okay, this is our data with some target. My target is I want to create a predictive model for predicting the disease, or for predicting customer churn, or predicting the fraud in the transactions. Okay, so I have a historical data with this pattern, like with so and so details. There is a target value, whether 0 or 1, or with some number. Okay, so my job in the model building is to come up with a model which is giving me the best accuracy. Okay, so that is what we used to develop in the model building. So we have to try multiple algorithms, and we have to choose the algorithm one which is giving us the best score in both supervised as well as unsupervised. So in unsupervised, we don't have any specific target, no specific target. It's all about grouping the customers. You heard about customer segmentation, market segmentation, clusters. So these concepts comes under unsupervised machine learning, where there is no specific target. It's all about grouping the data which are having similar characteristics or attributes. Okay, so that is what unsupervised machine learning algorithms. And the more advanced one is a deep learning and artificial intelligence. So once the model is ready, once you decide that your model, this model is performing better results or giving good results, so what you do is you are start going to deploy the model. So now you are all using Instagrams, YouTubes, Amazon, Flipkart, right? Every application in the backend, there is a AI ML. So they have deployed this model into their applications. They start they start doing the recommendations. They start doing the predictions based on your data. You are getting the recommended videos. You are getting the recommended products. You are getting a recommended, offers. Okay, so this is what the workflow uh, we follow as a data analyst and as a data scientist. Okay, at each step we have to learn very different techniques. Okay, brief summary about is that, like, there is a company, okay, e-commerce company, where they have both online and offline stores. Now the objective of the problem is, so they want to decide whether to focus their efforts on the mobile application or a website. Okay, so means they want to develop uh, either their mobile application user interface, or in terms of functionalities, or a website. Okay, so they have hired a contract, a person, okay, to help them to figure it out. So to decide whether they have to go with mobile application or a website. So this is the problem statement, and we have some data. So you can see the script for reading the data. So just one line of code in Python we have written to get the data. Okay, so by this step you can understand how simple the language is to learn. So you don't have to write lines of code for a single task. So if you want to read a data from any source, you just need to use one single function. That single function will get all the data for you. So as I mentioned previously that there are packages in Python. There are so many packages in Python developed to do different activities, okay, for reading the data, for doing the analysis, developing the machine learning models and everything. Only thing is you need to understand what is the purpose of that function. That's it. You don't have to write a lengthy scripts. Okay, so the first step, as I mentioned, we are reading the data. Now once we read the data, right, once we acquire the data, as I told you that we have to perform exploratory data analysis. So in exploratory data analysis, we are going to understand the data in detail. It's not like a high level overview. So in depth view, we need to understand the data. So then only you become a data analyst or a data scientist. So you should have a strong knowledge, a grip on the data on which you are working. So here we have simple analysis information about the data, which you can see here. What are all the columns and what is their statistics? Okay, so here we are, this is about the first 5 rows of your data. This is what your, whatever the data you have inputted, right? So this is the first 5 rows of your data. The next thing, the information, our metadata, right? How many rows, how many columns we have. Next, the descriptive statistics. So I said, like in the Venn diagram of data science, which I have we discussed about interdisciplinary field where you need a statistical skills. So here is the statistics which we have to check on the data, like what is the count, what is the mean, what is the standard deviation, what is the minimum value, maximum value, 25th percentile. All this information we have to understand. Okay, let's say average session length is 33 minutes. Okay, so on an what does it mean? So it means that on an average each customer is spending 33 minutes. Okay, means each session for each customer is taking 33 minutes. Okay, and what is the time and of app, in the sense application. Okay, so on an average it is a 12 minutes, and website which is a 37 minutes. Okay, so like this, a statistical information you have to extract from the data. The next thing, again, as I said, like visualization, correlations, distributions. So these visuals you need to understand, you have to create. So as I told you here, for visualization you can use Power BI, or you can use Tableau, or you can use Python, whichever the tool is comfortable to you to understand the data, you can use it. Okay, so here we are showing the correlation between the time on the website and the amount or the revenue we got. So this is the pattern, this is the pattern, and this is what the distribution we call. So this is a pattern or a correlation. Okay, so this kind of distributions and correlations we are going to create. Again, if you see, it is all about one line of code. Okay, so again, this is also a correlation between the mobile application and the revenue. So from this, from this image, so I can see that I don't see any correlation between the revenue and the website. So it's all about center. But if you see the revenue between, the correlation between the mobile application and the revenue, you can see some increasing trend. Right? So here I don't see such kind of increasing trend or something. So it's all about random. I cannot guess. So if you ask, sir, if I develop a website, so what is there a chance of increasing the revenue? So from this visual, we cannot say such kind of, we cannot guarantee such kind of statements. Okay, but here with this data, we can say that yes, so there is a probability, the revenue will increase if you focus on the mobile application in terms of user interface or functionalities, all these things. Okay, so that is this kind of insights we have to extract from exploratory data analysis. So once the exploratory data analysis part is done, then the model building part comes into picture, where we divide our data into training and testing, because we have to test our model, whatever the model we are building, how your model is performing on unseen data, right? So that's why we have to split our data into training and testing, and then we develop the model. Okay, and we calculate the accuracies, so which you can see here, the accuracy of the model between the actual data and the predicted data. Okay, so once, so here there is, so as an example, I have taken only one algorithm, but in real time, as I mentioned earlier, that we have to try with multiple algorithms. We have to try with multiple algorithms. We have to do multiple experiments, and then finally we have to check what is the accuracy of each algorithm. Let us say the R square, which you can see here, which is 98%. This is what the accuracy we call. So there is a 90% accuracy, means this model suits your data. Okay, so 90% accuracy. So this kind of accuracy we have to calculate for each of the algorithms, and we are going to deploy, or we are going to use the model one which is having the highest accuracy. Okay, so this is what the project life cycle or project flow, uh, as a data scientist or as a data analyst we used to follow. Okay, so the conclusion, so final conclusion, obviously we have to make, right, like which one we have to go with. So here you can see the coefficient, like which is a 38 and 0.19. So by seeing this, so there is a more weightage. So if you see here, there is a more weight, a time on app compared to time on website, right? This weight will help the decision makers to take the decision whether they have to go with application, mobile application, or a website. So this coefficient will help them to understand which application or which tool they have to focus on first as a priority. Okay, so this kind of basically, it's all about playing with data, as I mentioned, playing with numbers. So the number is having some sort of story, some site interpretations. Okay, so this is what we do in our real time, guys, and this is what you are going to learn in this course. So from the beginning, starting from Python. Okay, so we are going to start with Python. We'll understand some fundamentals of Python, then we are going to learn some advanced Python skills for data analysis. So how can we use pandas package, numpy package for data analysis, data manipulation. Okay, and then we are going to discuss about statistics. So in the same order, whatever the project flow we are following, so it's not a random steps. So this process we have designed because we are following that one. So at each step, what are the skills you need to have? So we kept all the skills in that module or in that endpoint. So this is what all about data science and its workflow. Okay, and what are the rare qualities now? So that is why the demand as well, because of so much data it is there. Okay, now if you go and search the latest trends or markets, what is happening in the industry is like, you can see there are so many people like who are at manager, middle management level, who are just doing the presentations or kind of creating a predict presentations, are managing, so their jobs are laid off because of these not having these skills. So you can go and check in the recent, Microsoft laid out 6,000 plus its employees who are at middle management. Why? Because they are not having a skills in AI and ML, right? And there are so many news, like there are so many jobs people are losing because not having these skills. So if you want, so this is your this is the time for you people, because you are all students. Okay, so you are in second year, third year, right? So it's time for you to start your career in AI ML, right? And get a job after your you know college. So that's all about for today.